Welcome to Module 2, Lesson 17, which is actually the first lesson in the topic C, which is the last topic for this Module 2. And the title of this lesson today is Comparing Tape Diagram Solutions to Algebraic Solutions. Now the whole theme of this module, this topic C, is applying operations with rational numbers to expressions and equations. Okay, and one of those first steps is steps we're going to take is we're going to compare tape diagrams, which I've attempted to get you to use. Again, this was a strategy that was or is employed in this curriculum, starting in second grade or so. So a child who is starting second grade and doing this, and by the time they're in seventh grade, they will have done many tape diagrams. You guys and girls haven't actually had that situation, but hopefully we can do this enough, and it's simple enough that you can grasp this idea. So what we're going to do today is we're going to compare using a tape diagram to solve a problem, and compare that to an algebraic solution. Okay, which is going to take a step-by-step process. And I will reiterate this. I will say this again and again and again. This is about the step-by-step process. So even though you're going to see a problem and you're going to know the answer quite quickly, which is great, you are still going to need to show that, demonstrate that you have proficiency in writing it step by step. And there is truly a method to this madness, and there is a reason. So please do bear with me. Okie doke. So yeah, with no further ado, let's get started. Okay, so this whole first activity, this classwork portion, if done in a classroom, I would present a few different scenarios or a few different situations, one to each group. And as groups, you would solve these problems algebraically, and as well as using a tape diagram, and then present them to the class, and we would all share all the information. So as we are not in a class, I will have all of you, I will present these scenarios to each and every one of you separately, and you can solve them yourselves. Gives you a lot more practice with it as well. So here is this exploratory challenge: expenses on your family vacation. Now here we go. John and Ag are summarizing some of the expenses of their family vacation for themselves and their 3 children, Louie, Missy, and Bonnie. Write an algebraic equation. Create a model to determine how much each item will cost using all of the given information, and answer the questions that follow. Okay, so this model that we're talking about here is a tape diagram. Okay, an algebraic equation. We will begin to work on that more precisely. Okay, so everything that you need to know, all the information you need, is presented right here in these expenses. So they're actually summarizing, or they're looking over the expenses that already occurred, or they've already incurred. Okay, so this is past tense. All right. So all the questions, or all these scenarios that I'm about to present to you one at a time, are all going to be based on these costs here. Okay, this is what they paid in total for car and insurance fees, baseball games and hats, airfare and insurance, movies for one day. The first scenario actually deals with this number, this total. Sandals and t-shirts when I was shopping one day, motel and tax, soda and pizza. So all of these costs were incurred by the family during this vacation. Okay. And you notice there are 5 family members. That number 5 is going to be critical. Okay. All right, so let me go ahead now, and you can just keep flipping back to this to these figures during the course of this this exploratory challenge, and you're probably going to need some. Well, you have some space in your binder, but you may need some more paper, so you might want to have that at the ready. Okay, so let's go ahead and I'm going to write down scenario number 1. Okay, so here's scenario number 1. Now again, we are working with information that you already have. You already have a total price. If you actually take a look back there, take a look at the total price for movies for one day was $75, okay? And that's what this scenario deals with, is that $75 price or cost. Okay, so here we go. I'm going to read it for you here. During one rainy day, the entire family decided to go watch a matinee movie in the morning and then a drive-in movie in the evening. The price for the matinee was different than the price for the drive-in. The matinee tickets were $6 each. How much did each person spend that day on movie tickets if they all paid the same amount? And another question, how much did the drive-in tickets cost? Okay. So again, some key information. We know the $75, and I'll get a clean sheet of paper here so we can do this on a clean sheet. But we know there's $75. We know they went to 2 different movies. Okay, so they went to see a matinee, and then they went to see a drive-in. Okay, so 2 different events. Okay, and the matinee price was different. Okay, so the prices were different. So we're going to need 2 different totals. We already have the $6 for the matinee. Okay, so we want to know, another very crucial thing is they all spent the same amount, or paid the same amount, because there is a possibility, of course, that a ticket for a child's ticket would be less than an adult or a senior citizen, but there are no senior citizens here. So anyway, and we're going to answer those 2 questions. How much did each person spend that day? And then how much did the drive-in tickets cost? Okay, so let's go ahead and sort through all of this, and if we take a look, so we have $75 is the total. Okay, that's the total, and now we know $6 is the matinee. Oh, spelling that wrong. Matinee. Okay, and the one unknown is the drive-in movie. Okay, so we're going to need to solve that. So solve for that. So we want to go ahead and just apply a letter. Let's just apply E to that as the evening movie. Okay, so that's the drive-in movie. Drive-in movie, or you could put D, whatever, but I'm choosing E, so the evening movie. All right. So here we go. We have these 3 things. Okay. Oh, another thing we have is we know we have five individuals, which is really important. Okay, and we know that they all spent the same amount, so that 5 is going to hold true. Now, if we go ahead and use a tape diagram, again, I'm going to do this one exclusively with you. Do this together, and I'll let you try the others by yourself and then come back and check. But for this one, let's just go ahead and look at this in terms of a tape diagram. And if you remember, the tape diagram idea is that you are creating, it's a piece of tape or a strip here, and we have 5 individuals, so we have 1, 2, 3, 4, 5. We've split this up into 5. These, of course, are 5 equal pieces. What we know about this whole thing is that this whole thing is worth $75, okay? Because that's right here is our total, okay? We have a total $75. We have it split into 5 equal pieces because we have 5 individuals who paid the same, okay? And now, speaking arithmetically, in terms of arithmetic, we know that each paid $6 for the matinee. Okay, paid $6. And then they paid something else for the evening movie, but we don't know that evening movie. Okay? We don't know the cost of that evening movie. All right, so we're going to just put plus E. So for each person, we have 6 plus E. I think this looks kind of silly, but 6 plus E. All right, that equals. So if we have 5 of these 6 plus E's, that's going to give us $75 total. Okay, so 5 of these here, 6 plus E's, are going to give us $75. Okay, so let's just look at what we know right now. So we have $75. Okay, we know it's our total. Now we can go ahead and just take away the 5 sixes here. So if we take away, we can multiply 5 times 6, okay, which equals 30, of course. So 75 minus 30, and that equals 45. So the unknown portion of this is the $45, okay. Now if we have 5 different E's, so that means $45 is the same as or equal to 5 times E, or 5E, or we could do it this way or any other way, okay, that unknown. So very simply here, if I know 45 equals 5E, all I have to do then is divide 45, of course, divided by 5, and that's going to give me my E price, which equals 9, okay. So every E, therefore, could be substituted for a 9. And if I went ahead and did that, I can go ahead and answer my question. So let's go back to that slide and answer those questions. And the first question was this one here: is if they how much did each person spend that day on movie tickets if they all paid the same amount? So we can go ahead and look at that. Look at our... Okay, and we can see that if they paid 6 for the matinee, and then 9 here for the drive-in, because that was the evening. That's what the E stood for. Each of our E's equals 9. Okay, so we could put that over here. 9 equals E, or E equals 9. So we would just add 6 plus 9, and that would equal $15. Okay, so that's the answer to our first question. Each person paid $15 each per person that night. And, of course, the other question, second question, is answered as well, because that asked how much did the drive-in movie cost, and that cost $9. So that's using a tape diagram. Pretty simple process, really. Now, looking at the same problem algebraically, again, our information is the same. $75 is the total. $6 for the matinee. E is going to stand for the drive-in movie. And then we have 5 individuals. We know we need to create an equation, so we know there has to be an equal sign in the middle. So we're going to put $75 on this side because everything that's on this left side needs to equal $75. Okay, so it needs to equal 75. So what do we put on this side then? Well, we have 5, and everything is equal. They're all equal, and the price for everything is going to be the same, for each person. So we just need 5, and then in parentheses we could put E plus 6, or 6 plus E. Okay, and there we go. We have that. So what we have here is we've taken care of the 5 individuals right here, because everything is going to be the same. We have our $6 for a matinee. We have our E for every person. That's our unknown. And then we have our 75 over here. So we have all of our information in here. And we know it's right because we know that this left side and the right side have to equal each other. Okay? And therefore we have the equal sign in the middle. Now, if you remember, we talked about I think it was lesson 16, the distributive property of multiplication. Okay, distributive property, we can apply that right here to the left side because we could just go 5 times E is 5E. Okay, and then plus 5 times 6, which is 30, and that equals 75. Okay, so we've taken everything out of the parentheses now. And again, if this might be new to you, I'm not really sure to some of you, but yeah, multiplying a number or an integer here, in this case 5 times e, which is an unknown, doesn't get you anything but 5e. Okay, because it's pretty much what this says right here is 5 times e, but that's the way it's expressed. Okay, 5e plus 30 equals 75. Okay, now we talked about a couple of times. Some of you again are much more proficient with this than others. But what we need to do now is we need to isolate the unknown, which in this case is this 5e. Okay, the entire thing 5e. We need to start isolating that e on one side, and to do that, we need to get rid of this 30 as our first thing. So we need to subtract 30 from here. But at the same time, we always have to remember we need to subtract 30 or do the same exact thing to each side of the equation. And that's that whole idea of balance. Okay, always remember you're trying to always achieve balance. So when you think of an algebraic problem, just think of this side balancing this side. Okay, so it's a balance scale. Think of a balance that's balancing. So if I take off 30 here, I'm going to have to take off 30 on this side. Okay, so if I do that, then I end up with just 5e, because the 5e remains. I haven't done anything to that yet. Equals 45, because I've subtracted 75, take away 30. Okay, so I have now what I'm left with right here is 5e equals 45. Okay, so I mean I can do that right here because I know I can see that 45 divided by 5 is 9. Okay, but if I want to do this more correctly, I would go ahead and I'm going to divide both sides by 5, or I'm going to multiply both sides by 1/5, okay, which is the same exact thing. But if I were to go ahead and do that, I could put 5e over 5, okay, equals 45 over 5, okay. And again, I am dividing by 1/5, I'm multiplying by 1/5 or dividing by 5, because that's what fractions are, 45 divided by 5, okay. So if I do this over here, I'm left with e, because 5 divided by 5 is 1, all right. E equals 9, okay, because 45 divided by 5 is 9. And here is my answer. Okay, so now I know that my drive-in movie, I get that answer first, well, like I did on the other one as well, but I get E equals 9, okay, and therefore I can solve my problem because I know now that the drive-in movie is $9, and the other question was how much did they pay total. Each one of them was $15 because 6 plus 9 was 15. Okay, so this is basically, for me, probably the easiest way to solve it algebraically. I mean, there can be other possibilities. And again, for some of you, you might have looked at it and said, wow, I know this really quickly, right away. I know the answer. And yeah, you probably did. But taking these steps, these individual step-by-step process is what is now most important. Okay, and here's our scenario number 2, and again, realizing or understanding that you have your first page of lesson 17 in your binder goes over, or actually lists the different prices, different total costs for the entire vacation. So you're going to need that information as well. So here we go. Here's scenario number 2. For dinner one night, the family went to a pizza parlor. Okay, I put a little article in there. To a pizza parlor. The cost of soda was $3. So the cost of soda was $3. If each member of the family had a soda and one slice of pizza, which that would never happen in my family. How much did one slice of pizza cost? Okay, so again, just like the problem prior to this, you have an unknown. Okay, and that unknown is this one slice of pizza. We have our known value, which is soda, is $3. And we also have another known value, which is that the soda and pizza total, which is on the first page of your binder, was $37.95. Okay, that was $37.95 was the total. I'll just show that to you. So total for pizza and soda. Okay. All right. So what I'd like you to do is I would like you to try this on your own. Again, solving for the one slice of pizza, which is our unknown. And come on back and we can do it together. Okay, I'm not sure how many of you used the tape diagram, but I did mean to have you use it first, okay, before you solved it algebraically. So here's what it would look like as a done tape diagram form, okay. Again, just having our numbers or our totals at hand, okay. Total $37.95. That was the total pizza night. We know soda is $3, and our unknown, of course, is the P, which is pizza. Family members are 5. Okay. So setting up the tape diagram, of course, 5 equal pieces. Well, they don't look equal, but they are equal. The entire thing, the whole, of course, is $37.95. Okay, and each piece of this diagram, okay, is P plus 3, okay, P plus 3, because we have our 3, which is our known for the soda, and our P is of course our unknown, which is the cost of pizza, which is what we're trying to solve for. So anyway, we have all that. I laid that out, and then next, of course, I'm first going to figure out what would all the soda cost. That's 5 times 3, because I have five threes right there. Okay, that equals 15. I take that away from my total, okay, which leaves me with $22.95, $20.95, and I know that's the total cost of pizza. And of course, to find my individual, each person's share of that pizza cost, what I need to do is divide, doing my long division here, and I come up with each person's slice of pizza costs $4.59, and I sure hope that was a good pizza, because that's surely an expensive slice of pizza. I hope that slice of pizza was the size of a dinner plate, because eating one slice of pizza only is crazy. Anyway, yeah, so there we go. That is tape diagram wise. Let's go ahead and look at this algebraically now. Okay, so just like the problem that preceded this one, here's what the pizza price problem looks like algebraically. And again, set up exactly the same way. Okay, what I've done is I've again just taken 5. Oopsie, I didn't mean to do that. Took 5 and then multiplied it times P plus 3. Okay, because P being the pizza price and 3 being the soda price, because everyone pays the same. And of course, equals, set up my equation, my balance scale here equals $37.95. Now, interestingly enough, if we look at this compared to the tape diagram, you can see it's exactly the same, because here we have 5 P plus 3s, right? Okay, 5 P plus 3s, and they're all equal to $37.95. That's exactly what this says. 5 P plus 3s, okay, is equal to $37.95. So this tape diagram can help you, give you a visual to look at or to imagine when you're doing problems like this. So here we go, and again, just continuing the process like we did last time, using distributive property again. Distributive property of multiplication to take apart that parenthetical expression. So now I have 5p plus 15, because again, 5 times p, and then 5 times 3, and that's equal to $37.95. Got that? Now again, I'm going to try to isolate. I'm trying to isolate the p on the left, the unknown. So I'm going to get rid of 15. I'm subtracting 15 from both sides, here and here. Okay, check. And what that leaves me with now is just 5p solely, because these two cancel each other out. If I do the subtraction, 37.95 minus 15, I end up with 22.95. Again, which looks very, or exactly the same as right here. As you can see, here's that 27.95, because I took our total and subtracted away the 15, which was this 5 times 3 here. Okay, so you see these similar number, similar pattern. Next step is to do the division, because I want to turn this 5p into a single p, because I'm trying to find out what one piece or a unit price of pizza, what price per slice. Okay, so I want to divide that by 5, and I do that here. Okay, and then I have to, of course, keeping the balance right, I have to divide the other side as well, divided by 5. And if I do my long division, I end up with my final answer, p equals 459. And again, a direct correlation to exactly what we did over here with the tape diagram. We divided 22.95 by 5, and we ended up with 459. Okay? So hopefully this is becoming clearer and clearer, simpler and simpler. And I'll tell you honestly, this part of algebra is the most fun. It's not totally panicky quite yet. We're using small numbers, small integers right now. Yeah, so have fun with it while it lasts. Okay? So again, I'm going to present another few scenarios. Actually, I have a scenario 3, which deals with baseball game, 4, which deals with some shopping, 5, which talks about their airplane and their airline tickets, and then the car costs in scenario 6. Now, I'm not going to go over it step by step like I am here, okay, because you can just refer to what I've done. They're all basically going to be the same. If something dissimilar shows up, I will come back and I'll help you with that one. Okay? All right, so here comes scenario 3. Okay, here's scenario number 3. One night, John, Louie, and Bonnie went to see the local baseball team play. They each bought a game ticket and a hat that cost $10. How much was each entrance ticket? So this is the question we're trying to solve right here. How much was each entrance ticket? So the price per ticket. Total cost, and again, this comes from that table or chart or list in the first page of the lesson. Okay, total cost was $103.83. And one thing, I'll just give you a little tip here. We're not using the number 5 now, because we only have 1, 2, and 3 members of the family that went to the baseball game. Okay, so remember now when you're working this out, tape diagram is only going to be 3 pieces, 3 sections instead of 5. Okay, and always looking closely. Don't assume things. Since we've been using 5, we used 5 twice, but now we're going to be using 3. Okay, I'm going to have you go ahead and please pause, do it yourself, come back. This is pretty straightforward, standard, just like the others, nothing new thrown in, so I'm just going to have the solutions written out and have you just check them against my solutions. Okay, tape diagram-wise, the baseball game problem. Here we go. Here's what it looks like. And again, I chose T to be ticket, to stand for my unknown ticket price. And you may have put something else. Doesn't matter. Okay, that unknown letter has very little significance, except that you just need to make sure, especially when you're solving algebraically, you need to pay attention to keeping it the same throughout. All right. Again, you can see what happened. Took away, calculated what I knew, took it away from the whole got the balance, what was left, divided that balance by the three people, and got my per ticket price, $24.61. Alrighty, here algebraically, set it up exactly the same as we have been throughout this lesson, keeping everything balanced throughout. Distributed property to get that, take away, to get all that parenthetical stuff out. Subtracting away my 30 from both sides, keeping the balance, trying to isolate the t's. Okay, I have 3 t's. I want to get that 3t down to 1t because I am interested in a per ticket price. And I divide by 3, therefore, and I divide by 3 on this side, and I end up with the same answer as my tape diagram. Ticket price, each ticket equals $24.61. Okay, this next problem throws a few different elements into the mix. So we will, I'll just send you off, and we'll read it to you first, send you off, get you working on it. Come on back if you're not quite sure how to set up your tape diagram or how to do it algebraically. So it's a little bit different. So let me read this scenario for you. While J, L, and B, while John, Louie, and Bonnie went to see the baseball game, Ag and Missy went shopping. They bought a T-shirt for each member of the family. Very important to know, each member of the family, and bought 2 pairs of sandals, and that cost $10 per pair. Now, what they want us to solve for here is how much was each T-shirt. Now, the total that they paid, again, this is from your from that chart in the front of the lesson. The total cost of everything was $120. Okay, so we have that. We have the total. We have the sandal cost per pair. But what we want to know is how much each T-shirt costs. So I'd like you to try and set this up as a tape diagram, and then go ahead and do it algebraically. Come back and check. I'll be a little bit more extensive in my checking over of this one, as it presents a few more elements, few that are a bit different. Okay, and as you can see, setting up this tape diagram for this problem was a little bit different than the others because I had a few new elements. All right, we had 2 pairs of sandals. Okay, so we needed 2 pairs of sandals. So I know that per price already of the sandals. So I am going to represent that on my tape diagram as these two. These two are knowns. Okay, they cost $10 each, and they're going to be presented right there. Okay, all the T-shirts are unknown, and as I bought 1 per family member, I needed 5 of those. So my tape is actually has been divided into 7 pieces because there are 7 pieces of apparel that I am buying. I am buying 5 T-shirts and 2, not me, but they bought 5 T-shirts and they bought 2 sandals, 2 pairs of sandals. Okay, so as they bought 7 pieces, that needs to be represented on my tape diagram. And again, my total cost, of course, is going to be the $120 that we presented right here. Okay. Okay, then it becomes a pretty simple problem after that. Again, very similarly, whatever I have as my known, I'm going to go ahead and total up. Okay, and that happens to be the 2 10s right here. Whereas before we had, we might have had E plus 5. We knew the 5s, so we added all those up first, for example, in problem prior. But with this one, we're going to add those 2 10s up. We get 20. And then that 20 we're going to go ahead and take away from the total. And we have our balance here, which is left. We have $100. Now that $100 is represented in the 5 T's. Okay, so 5 T-shirts actually cost us $100. So we go ahead and divide that by 5. 100 divided by 5, and that equals 20. And then so we know that T, and the answer to our question is each T-shirt. Each T-shirt cost $20. Okay, now algebraically it looks a little bit different. Whereas before we had to use distributive property because everyone had the same amounts applied to them. This is a little bit different because we have these two pairs of sandals that are on their own, residing on their own. So I set up my first problem as this: 5t, which is my unknown, plus 20, which I know already because that's my 2 times 10. Okay, all that equals 120. Again, we have our balance. Again, trying to isolate the t. First start by isolating the 5t by removing the 20 from each side, as we did here. We end up with 5t equals 100. We do our division down here to isolate 1t, because we're trying to find a per t-shirt price for each. 5t divided by 5, 100 divided by 5, and we come up with t equals $20, just like we did before. If we were to extend that at all, I mean, our initial problem could have been 5t plus 2 times 10 equals 120. This, of course, accounting for the fact that we had two pairs of sandals at $10 each. But yeah, either way is correct. Okay, in this next problem, the scenario 5, similar to the ones prior, the first few we did. The family was going to fly in an airplane to their vacation destination. Each person needs to have their own ticket and also pay $25 insurance each. What was the cost of one ticket? Okay, I'm going to let you find the information you need by yourself, the information that you need from this problem and also elsewhere in the packet. So go ahead and come on back, and I'll have the solutions first for tape diagram and then algebraically. Okay, tape diagram wise, here's how I set it up. Now that we have everyone with the same costs, we have t plus 25 5 times. We have our total. Okay, tape diagram set up. Solving for the tape diagram, we take care of our knowns first. We know that 5 times 25 is 125. Subtract that away from the total. Now we're left with our balance, so 750 has to be divided into 5 separate pieces to account for each member of the family. We do that here with our long division, very simple long division, and we end up with one ticket costing $150. And here we are again algebraically. Again, very similar to what we've seen. 5t plus 25 equals 875. Distribute that out. 5t plus 125 equals 875. Subtracting away the 125 to isolate the 5t from both sides gives us 5t equals 750. We're trying to solve for 1t because we want to find a per ticket price, and therefore we divide both sides by 5. We end up with our t equals $150, or each ticket equaling $150. Okay, here's scenario 6. While on vacation, the family rented a car to get them all over. And I was trying to use less words here. Start again. While on vacation, the family rented a car to get them all over. The car costs a certain amount each day, plus a one-time insurance fee of $50. How much was the daily cost of the car? So that's what we're trying to find. How much was the daily cost of the car? Now that is not including, very important piece of information, not including insurance. Okay, so we're taking this is going to be a one-time fee, and take that out. This is going to look very similar to or should look very similar to the sandals and t-shirt problem. Okay, so go ahead and solve that tape diagram algebraically. Come on back, I'll have some answers. Okay, setting this up as a tape diagram. Have all my information. Total 400. Insurance one time. A number of days 5. Okay, very important when I'm setting up my tape diagram, because the tape diagram is going to have actually 6 different elements, because the first element here is the $50 one-time charge, okay? And then these 5 C's are for each day, so day 1, day 2, day 3, day 4, day 5. You might have used D. I used C. Okay, so all of that, these 5 C's plus the 50 are going to equal up to 400 now. Pretty simple from there then. I go ahead and take my 50 that I know, my known, subtract it away from my total, and get my balance right here. Then I'm going to just divide my balance by 5 because I have 5 different days worth of car rental, okay? And I get $70. So my C, so the car cost per day equals $70. $70 per day to rent. And here it is algebraically. Set it up, 5C, those are my 5 days of car rental, plus 50 was my one-time insurance, equals my total 400, which I was given in the first page of the packet of this lesson 17. Isolating 5C by taking away 50 from each side leaves me with 5C equals 350. Again, I'm dividing by 5 now because I want to find out the per day price of a car. Okay, divide both sides by 5 and I end up with C equals $70. Okay, here's a 7th and final scenario. The family decided to stay in a motel for 4 nights. The motel charges a nightly fee plus $60 in state taxes. So this is going to be just one flat tax fee in this scenario here. So and the question is, what is the nightly charge? Okay, nightly charge without the taxes included. And we know again from the page 1 in the binder that the total for motel and tax was $400. Okay, so like we've been doing here for several times now, go ahead and set yourself up, tape diagram, and then do it algebraically. Come on back and we can check them together. Okay, here's our tape diagram, and again I hope you're getting more and more used to these, so you use the correct number of elements or number of pieces on your diagram. Again, I have 5 pieces here because I have my one-time charge or the taxes of $60. Then I have my 4 days worth of nightly charges on the hotel or motel, and those are my unknowns. Take away that, and my total I know is 400. I take away my known total of 60, left with my balance of 340. Divide that 340 by 4 because it's 4 nights worth, and I get 85. So my nightly cost for the motel, $85. And hopefully this algebraic process is becoming second nature to you. And again, the more and more we practice this at this level using simple numbers, the better you'll become at it. Again, 4n plus 60 equals 400. That deals with my 4 nights of unknown price plus the $60 one-time tax charge equals 400, which is my total. Taking away the 60 because I need to take away, I need to isolate that 4n. I did that here, equals 340. Again, I want to know per night. I need to divide that 4n by 4 to get it down to 1n. And of course, I divide my 340 by 4 to keep the balance, and I end up with n equals $85. Okay, so we're finally now to the second page of your binder, lesson 17 in your binder. And so if you would just go ahead and pause now and just write all these down. I mean, I know you have it probably somewhere. If you've been doing these along with me, you have it on your pages and pages of calculations we've been doing. But you can pause this right now and just write all of these costs down on this chart, on this table that you have on that page. Okay, so go ahead and do that, and come on back, and we'll go ahead and answer those 2 questions, numbers 1 and 2. We can actually do that together. Alrighty, so come on back when you're done. Okay, so now it's kind of turned a little bit here. They've asked you before to use like a total, use the total that was known, and kind of back into a per unit price, per ticket, per day charge for the auto rental, etc. What they want to do now is actually take what you know, which is all of this on this chart, and apply it to these problems. So it says here, using the results, determine the cost of the following: a slice of pizza, one plane ticket, 2 nights in a motel, and 1 evening movie. Okay, so we're going to need a few pieces of information to do that. Let's go back and get those. Okay, so I've just written down here the per unit prices for all of these, so I don't have to keep flipping back and forth. But if we're going to go ahead and write an equation for this, we could just do it this way. A slice of pizza is $4.59. Okay, and we are adding here, so plus 1 plane ticket, which is also just $150. And then to do these 2 nights, you would go ahead and again just do 2, and then put the 85 in the parentheses. This is the proper way to do this. And then plus 9, and then if we went ahead and did all of our, well, actually, we could do, again, this is all going to be, it's still going to be $4.59 if we wanted to do this step by step, plus 150, and now we're just, kind of distributing that out there. That's 170 plus 9, and that is all going to equal $333.59. Okay, so now that you've seen how to do this, would you go ahead and do number 2 to yourself and see what you come up with? Okay, that wasn't challenging at all, but yeah. So again, 1 T-shirt, 1 ticket to a baseball game, 1 day of rental car. Pretty easy, just because everything's 1. 20 plus 24.61 plus 70 equals $114.61. Okay, here's an exercise just to finish off. I'd like you to go ahead and do this. Use a tape diagram, as well as solving this algebraically, and let's see what you guys come up with. Not entirely dissimilar from what we've been doing, but a little bit different. So let's see what you come up with. And here's the problem. Here's the exercise. The cost of a babysitting service on a cruise is $10 for the first hour and $12 for each additional hour. If the total cost of babysitting baby Aaron was $58, how many hours was Aaron at the sitter? How many hours? Okay, so this how many hours right here is going to become our unknown. Okay, and that's what we're solving for. So go ahead and see what you come up with in terms of tape diagram and also algebraically, and come on back and let's see how you did. So this one's a little bit different in terms of solving with a tape diagram, because you don't really know how many different elements you have. Because the idea, what we're trying to solve for here is how many hours, how many separate hours. Now we could divide this tape up into hours. That would be ideal, the ideal situation, okay? But the only thing we can do right now with this tape is actually, we know that one of those pieces of the tape, or one of those elements, is $10, because that was the cost of the first hour. We know the entire cost is $58, so we know that all of this is going to equal $58. But deciding how many pieces there are is hard to determine right now. But the way to do it here would be to go ahead and take that known right here, which is the 10, subtract it away from the 58, and we are left with a balance of $48. Now, what we can do therefore with that 48 is we can indeed divide, because we know each hour is $12. So if we went ahead and just took that total and divided it by each what each hour cost is, we would divide it this way, and we would come up, of course, 48 divided by 12 is 4. Okay, so we would have 4 more hours at 25, so we could actually actually complete this tape diagram now. Okay, and that's going to be 12, 12, 12, 12. The one thing about this question, though, is not to be fooled, because 4 is actually not our answer to the question, because the question asked how many hours was Aaron at the babysitter. And this is hour 1 right here, which is 10, hour 2, 3, 4, 5. So Aaron was actually at the babysitter for 5 hours. Okay? Algebraically, may look kind of straightforward, but again, gotta be careful at the end of this. The way we would set it up here, because for our unknown, because we're talking about additional hours now, we can set this up for our unknown, and again, it'll be 12h, okay, plus 10, okay, because that stands for that first hour, because we need to get rid of that, okay, because we're only interested right now in with the additional hour, how many hours those were. Again, taking that away, just like we would do it any time we do it algebraically, we come up with 12 hours equals $48. Okay, and like we did before, we want that per hour. We want to know how many hours it was, and we divide by 12, and we know we have 4 hours of the additional hours. 4 additional hours. Have to remember though that we have to add back that first hour. So we have 4 additional hours plus the 1 original first hour, which is going to equal 5 hours total. Okay, well, I hope you enjoyed this lesson. I enjoyed it. I enjoyed taking our time. Hopefully you took your time and doing each of those scenarios one at a time with both tape diagrams and algebraically, getting used to these processes with simple numbers. And again, here's our lesson summary, as we usually do. Very simply, tape diagrams can be used to model and identify the sequence of operations to find a solution algebraically. And again, just modeling it by showing the number of units, the number of elements that are there, and representing those the total as separate elements. The goal in solving equations algebraically is to isolate that variable. We talked about that over and over again. We're trying to isolate that variable, whether it was H for hours, or C for car days, or T for ticket. Okay, we're trying to isolate that variable. We want that variable on one side of the equation. The process for doing this requires undoing addition or subtraction by obtaining a 0, and undoing multiplication or division to obtain a 1. Okay, so when we undid addition or subtraction to obtain the 0, we subtracted away our known. When we knew the first hour in the problem we just did was $10, we had to undo it. We took it away. Okay, when we undo multiplication or division, we have to obtain 1, we are just dividing by that number. So if we had 5n equals 100, if you remember, we divided by 5 because we're trying to undo that multiplication, get it down to 1, because we want that the additive identity. We want 1 or the multiplicative identity, either 0, additive identity, or 1 is a multiplicative identity. Okay, so the addition and multiplication properties of equality are applied because in an equation A equals B, when a number is added or multiplied to both sides, the resulting sum or product remains equal. Okay, that is the trick here, is this is not just equal, but also to maintain a balance in an algebraic equation. Okay, whatever comes off of here, you're going to subtract A here, you need to subtract A here. If you're going to divide by 5 here, you're going to have to divide by 5 here. Okay, you're trying always to maintain a balance. So always remember, whatever you do to one side, you do to the other. Okay, that's lesson 17. Go ahead and get your problem set done and your exit ticket. All right, good luck and have fun. Try to have fun.